Hello, everybody who's joined us for this session. It's the second session of three. The first session, hopefully you were all there, but welcome to newcomers today as well. The first session that we did last week was on cloud fundamentals. In this session, we're looking to cover design, and that design will be both inside and outside of cloud, predominantly inside of cloud. We'll come to that bit in just a second. So as not to bore you with exactly the same introduction every time, we're going to try and do a pre-seed version for you. Trying to pre-seed anything for me is incredibly difficult. So here we go. My name is Justin Day. I'm the CEO and co-founder at Cloud Gateway. I come from a technical background. Haven't been on the keys for a long time. My kind of growing up in networks was telco based. I worked for cable and wireless for a long time, half my life in the private sector, half my life more recently in the public sector, and it was at the Ministry of Justice that I met Steve, who can introduce himself.
I'm Steve McConnell, CTO of Cloud Gateway, at least 3 times more technical than Justin, and still on the keys. So my background is private and public sector. I've worked on some big e-commerce platforms for gambling companies. I've worked in Capita on a big call center migration, and I've worked in the public sector on the digital prison program.
So talking about interaction, the interaction that we want from you throughout this session is that, we want to hear some of the things that you may have experienced that you didn't get an answer for, some of the things you may have experienced that you did get an answer for. Maybe it wasn't a satisfactory answer. Maybe you want clarity on something as to why you think someone or something might do that. Maybe you feel that a certain business type or a business in a certain vertical or sector would act or react in a certain way. We want to see those come through the session into the chat, where they will be delivered to me via the power of my offstage hand, and we can then talk about them on the board as we go. Apart from that, and getting some wonderful pleasantries through the week, as well as to how we got off to a good start, but we can definitely do better. For the benefit of Moira Roberts, I have changed my advertising super dry t-shirt. Hopefully this is more to your liking. So without further ado, let's talk a little bit about the fact that there was a world where cloud did not exist. So a pre-cloud world, which oddly wasn't really that long ago. I think we talked about the fundamentals, the kind of advent and consumption of the public cloud didn't really come to major fruition until the mid-2010s. I think a lot of that had to do with the fact that you had a maturing cloud in AWS, which I believe came to pasture in about 2006, and Microsoft's rise to fame with Azure was in sort of 2012, 2013. One of the things that we talk about a lot, though, and I think is quite important with networking, is that the fundamentals have not changed. The requirements and the desire. I need ultimately something that will allow me to get stuff from here to here as securely and quickly and cost effectively as possible. So we're going to look at, just quickly to set the scene, 2 different bits of networking. We said that we're going to focus ultimately on design within the cloud, but it's important to understand what design would look like, what infrastructure looks like outside of the cloud as well. And for those keeping score, what I don't mean is necessarily WAN and LAN, although within reason, that is probably what you're going to see here. But having that understanding of the fact that you've got a very specific set of design principles and considerations inside of the cloud is one thing, but outside kind of sets the scene for allowing us to get into that cloud, get out of that cloud, and kind of builds on some of the questions that we've been asked during the week, and hopefully some of the questions that you will ask as well. So without further ado, I will hand over to Steve, who is going to talk us through essentially nice high level, what a network looks like outside of the cloud.
Hi, everyone. So yeah, what we've got here is your typical WAN and LAN connectivity with the data center. And this is typically what the network before cloud looked like. So In your LAN here, that's where your users will be based, and that'll have an IP address or an IP schema in that. That will connect to your provider. That's the provider CPE equipment there, and ultimately they will control the routing in and out of the WAN. So things you see on the LAN, you usually have an in-house team or an outsourced. You could have an outsourced team to manage that, but that's where essentially you'd have your users based. So these three IP addressing schemas here under the RFC 19, they are essentially private addresses. They were assigned to be non-routable on the public internet, and most companies will stick to within these boundaries for LAN IP addressing. However, there are exceptions, and we have seen customers who use public addressing within the LAN, which can create further problems. So each LAN will have its unique address subnetted out of one of these, usually the 10 range, but you can use any of these ranges. We have to make sure they're not overlapping. That's one of the first things you need to do. So you need an IP address schema to make sure you've got no overlapping IP addresses, because that will ultimately cause you problems and you won't be able to route from one place to another. Your WAN provider will be typically your BTs, your Vodafones of the world, things like that, although there's smaller companies offering WAN now, and they would put a device in your site known as the customer premise equipment. That gives them the control, it gives them the ability to monitor the circuit there and the service they're delivering, and they can publish services to the edge here. Again, exactly the same in the data center. And ultimately, once you've assigned all your IP addresses to your LAN and your data center, and they're not overlapping, with your interior routing protocols, things like EIGRP, which was Cisco proprietary, OSPF, and I don't know whether to name it, but RIP, I've seen it used in the wild, or static routing. Essentially, that could be configured on the LAN to advertise those routes. What would happen is you'd then talk to the CPE equipment. They would then redistribute that into what's called BGP, or Border Gateway Protocol. BGP is a internet routing protocol or a WAN routing protocol. It has the reasons for that is as longer timers, so it can take a little bit of instability on the WAN, and it means your links aren't flapping up and down, your routes aren't flapping up and down all the time, causing conversions every 5 minutes, which again will lead to packet loss and unreachability. So typically in the data center, again, you'd have your internet access. You'd usually have a security device or a firewall at the edge securing your perimeter. From the data center, that would send really a default route into the WAN. Into the WAN. That means any traffic that isn't going to any of the other LAN subnets, because they'll be more specific advertised in, would head to the data center for the services up there, or any business applications or subnets that live up there.
Yeah, so one of the things sort of important to me, the reason I laugh at RIP, RIP is a routing protocol I've never used. I studied that originally back in 2003 and have never used it. So that is incredibly old. If you knew what that was, you're probably older than me, sad times. This here, RFC 1918. So RFC 1918 addressing, or you may have heard of as simply as 1918 addressing. Yeah, nothing to do with the end of World War II, is this, as Steve said, that is private addressing that is usable across your private space. As I'm sure Steve has, I think I know anecdotally he has as well. When people use addressing outside of this space internally, it can become very problematic indeed. You don't tend to see it very often, but when you do, that's a big red flag. I think Steve also touched on the internal or interior routing protocols. EIGRP, one of my favorites. This was a Cisco proprietary one that they really went heavy on and tried to introduce through the late 90s, early 2000s. As you can imagine, if I'm being slightly skeptical, that was to try and make sure that everyone was using Cisco equipment and nothing else. But it sort of ended up flaming out and slightly backfiring because it was just inoperable and very difficult to ultimately use with other routing protocols. I think what's important here for me as well is that I keep stressing it, is that this is fairly basic, really. This is kind of what everything attempts to look like, and without all of the bits that get stuck on over time as complexity is introduced, as businesses grow or they acquire other businesses or they change or departments move and do whatever they do. This is ultimately what kind of good would look like at its base. And like I say, the majority of the network outside of the data center, or indeed the public cloud, as it will be, will look like this. As Steve said as well, ultimately BGP is an exterior routing protocol. It's used predominantly across the internet, and when it's configured well, you don't get packet loss, and when it's not, things like this die for 30 seconds. Cheers. So that's a good example live. I promise you we didn't do that on purpose to prove a point, what that will look like. Now, we talked last time from a sort of a fundamentals design point of view that public cloud is just going to look like a little spoke out here. Instead of a square with DC in it, we're going to have cloud. So Steve, if you start to give us just the basic basic network design, a sort of availability zone setup. Let's not put any servers or anything in, let's not worry too much. What would that look like in cloud? I'll give you some time to draw that and have a little chat with everyone whilst we go. So yeah, so we talked about, like I say, public cloud, and I mentioned it earlier. I want to touch on it again, that cloud means lots of things to lots of people. If you remember, I kind of gave a more philosophical and probably slightly boring answer as to what cloud is, but for the benefit of not just this session, but all of the sessions that we're going to do, we're going to be talking about cloud as public cloud, and we're going to be leaning heavily on AWS and Microsoft Azure. If you'd wondered why we'd be focusing, or why we are focusing on those two when other cloud providers are available, there are many thousands of cloud providers. In fact, the reason that we're focusing on those two in the public cloud space is that they have the lion's share of almost the entire market. In fact, recently, I believe the Monopolies Commission got involved and started looking at how they are acting and how they have their market share. I won't get into the politics of that. I'm not interested in that. The point is, it really does prove that they have the lion's share. What will be interesting in the near future, I think, is to see how other major players, if not by name, rather than market share, will start to ingratiate themselves to the market. I think Google is one in particular I'm very interested in. They have a great AI position. Of course, AI, as we all should know, is particularly on vogue at worst and amazing at best at the moment. So I expect to see Google start to sort of force their way into that marketplace more, which of course sounds utterly preposterous when you're talking about a company the size of Google, but their market share in public cloud really just is not that big compared to the other two. So over to Steve again, who's given us, I say, a basic kind of design, and will talk us through. We're now talking about being inside of the public cloud.
Yeah, so what we've got at the top is a VNet in Azure. We've allocated a SuperNet or CIDR range of 192.168.0.0/18 for use within this VNet or virtual data center. And I've just created two subnets here. So we've got the first one, 192.168.0.0/24, which gives you 254 hosts available in that subnet. And again, we've used 192.168.1.0/24 in there. For the VPC, we've allocated a separate supernet, 192.168.64.0/18, and we've got the subnet 64.0/24 and 65.0/24 in here to make sure that we do not overlap those IP addresses and cause ourselves issues.
Okay. And how would we get them communicating to each other? Because I know we've got multiple ways we could do it.
Yep.
And of course, with design, there's never like a one size fits all. So give us a couple of flavors of just the basic connectivity of how we
can
get them to
the easiest way to connect these together, because they're in different cloud environments and there's no peering available, would essentially just be able to just create a VPN over the internet. So use the cloud native constructs within the cloud environments, create a VPN between them. If you want, you can run BGP over those VPN tunnels. I would strongly advise doing that. The reason being is if you connect any more subnets in there, they're automatically advertised. Again here, otherwise you have to use static routing and user-defined routes within the environments, which means you're just going to have to go into the route table, edit that every time you add something new. So VPN's probably the easiest over the internet to connect those together.
Okay. And as network people, we always like to probably have more fun with not internet-based stuff. What is a private way that we could achieve this? Let's assume that these guys are an established company. They have a WAN in place, whether or not they want it. They have classic MPLS-driven WAN. They've got their service provider. What's another way that could be pieced together?
Yeah. So the other way is obviously go to your service provider. Say you want to connect to your cloud environment on one of their provider edge or multiple provider edge bits of kit into your WAN, they would essentially connect those via express route there and direct connect there. And they should be using BGP between those environments again, just to make sure those are advertised to your sites, and your sites are advertised there to make sure the end connectivity is there. There's a couple of limitations here with AWS. If you're using the RFC 1918 address, and it's easy to summarize, you should only really have 3 routes, or maybe less than that sent to these cloud environments. With AWS, you can only advertise 100 routes. If you go over that, the BGP peering will fail, your connectivity will fail, it won't come back up. With Azure, I think their base offering is 4,000 routes, so it's a lot more friendly in that perspective. And if you pay for the high-end SKU, I can't remember what they call it, but that will then add 10,000 routes on there. So that's a lot more scalable if you've got a sprawling WAN and sprawling IP addresses and plenty of other services connected.
Mm-hmm. And to give people an idea, and I appreciate this will be different business to business, how many routes would you tend to see in a core routing table in a business, not in the cloud, in a core routing table, the sort of businesses we're used to?
Yeah, I mean, we can take some of the external networks we connect to, so sort of PSN, HSCN, things like that. There's a couple of thousand routes in there, at least 2,000. Mm-hmm. Some of the customers we have got over 3,000 and 4,000 routes within their routing table. So that can cause headaches connecting to AWS. What we tend to do is summarize on their behalf, or just only advertise routes up there that need to access it. Mm-hmm. So you've got an extra step there to essentially not go over that quota.
I think, well, I've always thought this is quite an interesting one. When we talk about the 100 routes, again, this is sort of, we're getting down into sort of network nerdy stuff, which is, again, this is design consideration. We talked about what Amazon and Microsoft kind of intended the public cloud to be. This, to me, is a brilliant example of not forward thinking in your design as to the basics of networking. And why would they be contemplating routing tables with more than 100 routes? Doesn't make any sense compared to how they originally intended this would be kind of one block, maybe a couple of availability zones. They wouldn't have expected to see masses of routes in there at all. They would have thought probably you've got one summary as Steve's put up here. So it wasn't that they made a massive mistake. It was that they're essentially considering something, or didn't consider something because it didn't need to be considered. So I think what's also interesting here as well, again, I said I've been off the keys. That means I get commercially excited about things nowadays. When we look at the fact that we could use a private pipe, or we could use, the use of the public internet to glue these things together. Question often asked is, what's right, what's wrong? Is there a sort of a one size fits all? No, there's not. Typically, and if you're with a service provider, it's not uncommon to have to go through all of the rigmarole to go through ordering, let alone the technical bit. So this can sometimes just be incredibly time consuming more than anything, which of course the internet typically isn't. If you've got control of your cloud environment and you want to build over the internet, then time is not an issue. You can build as you need to build. However, we won't get into at the moment egress data costs. I'm sure that's something we will cover another day, but ultimately you get billed for the amount of traffic you egress out of your cloud, and the price per gigabyte of that is cheaper if you are to use private networking than if you are to use the internet. In fact, it's 75% cheaper on average if you do that. Now, you'd have to move a lot of data to make that potentially thoroughly cost effective. But again, that starts to become a design consideration if you want to build in commercial ramifications as well. So we have a question that has been put into our chat, which is great. Thank you very much. So the question as it is here that I can read out is, as I increase my VPCs and VNets, should I just use VPNs across the internet? So essentially, I guess that's building on what we've got here. Yep. We've put 1 and 1. So my interpretation of that question is, if we go beyond 1 and 1, should I just keep using VPNs across the internet? And again, I guess Steve's going to draw. So I'll sort of give you a little bit of background on how often that comes up. A lot is the answer. I think clearly it depends. Steve straight away said, actually, a good answer to that one-to-one kind of scenario is that using the internet is a really appropriate way to go. It is. It's quick. It's simple. I'm sure there's some CISOs out there pulling their hair out and saying, yeah, but what about security? I I hear you. There are other ramifications as well. However, that one-to-one relationship, less of a problem. What we've tended to see, and I think kind of plays into the fact that this is a design session, is that there is not a consideration for how things will grow. Cloud, we talk about scalability in cloud all the time. There is a lack of consideration for forward planning, particularly with design. The fact that cloud allows you to turn the dial and things just grow, I think sometimes creates some poor behaviors in removing or reducing design function because you haven't thought about it ahead of time. So, Steve, what does it look like if we suddenly grow lots of VPCs and VNets?
So as it looks there, excuse me, it looks like a bit of a spider's web. So obviously, the more VPCs or VNets you introduce, the more VPNs you need. If you need connectivity between all of them, you end up with a spider's web of VPNs all over the place. You then have the complexity of routing over there. Like I said, with BGP, that will just inject the routes. If you're using static routing, that's something else to be considered, because every time you connect a new VNet or VPC, that's another one on. And then you could potentially, there's troubleshooting things you have to consider there, technical debt. It does get very messy if you're just connecting those. Like, obviously, if they were in the same cloud environment, you could get away with some of it by using peering. So you could pair these two with this one, these two with this one, then you could still have the one VPN. There's some technical considerations there as well about using the gateway for these VNets or VPC as well, but it can be done. But if you've just got 6 VPCs or VNets, you want to connect them all via VPN, it gets terribly messy.
So we're not necessarily saying that the internet is a bad thing here. We're saying it's an option. If you were to extrapolate that, and I'm conscious you're now going to have to rub the board again and draw again, we started seeing early on where, well, in fact, we started designing them because they were kind of obvious network designs for us. We started seeing transit VPCs and transit VNets to just simplify an architecture. What would that look like if you had a kind of a, your VNets on the south side, your VPCs on the north side, and you kind of had a common transit in the middle? What would that look like? I'll let you.
Well, we can probably go one back. We can probably talk about the transit gateway and Azure V1.
Okay.
That's sort of the newest thing. So yeah, if you had your AWS VPCs up here, you've got your transit gateway here. You've got your Azure VNets down here, and you've got your V1 here. You could essentially just connect those together over the internet. These would connect to the V1. Once you connect that to the V1, and you've got BGP running here, those VNets, those side ranges allocated to those VNets are automatically advertised. And you can tick on propagation here, which means they'll be routable. Same with the transit gateway attachments. You connect to your transit gateway, and again, you can do that. You can also attach things outside of your account to transit gateways and things like V1. So any third parties, arms, bodies, anyone else who you're working with can typically connect to there. So it does cut down on that VPN sprawl.
So this is Amazon world. This is Amazon language, and this is Microsoft world and Microsoft language. So I think we touched on this last time, but again, this was part of fundamentals, so we didn't want to go into too much detail. Just give us a little flavor of what V1 is and what transit gateway is. But let's start with V1, because I know that was interesting I think it was interesting for us when we first heard V1, mainly because it was A, Microsoft, B, cloud, C, use the term WAN. So you start stepping on network people's toes, like this better be good. So talk to us a little bit about
so V1 was essentially introduced to get rid of some of the issues with that transit VNet. And it made it more scalable. So you could attach different VNets to your V1, automatically connect those together. You don't have to worry about transitive routing. The V1 handles all of that. And that was their answer to the limitations of using that one VNet for connectivity, then connecting all that up. So it simplifies it. It's a lot more user-friendly. I worked with this when it was in preview for a customer. Again, it's a decent product, and it has simplified things a lot. It also connects globally as well. So it's not just one region, you can connect globally to the V1.
And I think this is interesting as well, because there is a near theological debate around whether the internet is appropriate to use as a WAN for business. Most people who enter the discourse are somewhat indoctrinated in their opinion rather than being objective. I think the general feel is that network people believe in MPLS and private networking, and that is the only answer. That's actually, sadly, let me debunk that right now. That's not true. It's for us about using the right tool for the right job. We can easily fall down a conversation about the internet and private networks essentially being the same thing on the same infrastructure, but let's not go down there. I think what's interesting here is what we haven't done is we haven't stepped away from using the internet. All we've done is design out that sprawl so that we know exactly what is where. It can be under greater control. There's greater visibility. Security people will be much more happy. There's greater consistency. Essentially, this is design, but the design consideration here is a network one. I think that's really important. It's not an application one, it's not a service one. It may even be that actually this is a bit of a pain for application and service. Maybe, I don't know, that's not my speciality. However, this is pure good design for the sort of basics of networking before, again, like I said, when we get into the nuance, there's certainly things we can pull out as well. So good news, we continue to have questions. So looks like this is going well. So question asked is, how should I design my cloud access when third parties I need to talk to use the same cloud? Again, I think my interpretation of that is third parties aren't necessarily like your SaaS providers. It might be that it's like a business-to-business relationship. So you have a relationship with but you have presence in, again, let's say Amazon. You want to do some business with a company who has presence in Amazon. How should we communicate? How should we stick that together? What are the ways that we could do that? What's the best ways? Same thing, I'm going to keep reiterating it. Is there a one-size-fits-all the best way to go? No, there never is. So what sort of things could we do? I mean, I know I'm sort of thinking sort of your VPC peering and also actually extrapolating it outside of as well, the sort of bounce out, bounce in type.
Yeah, so like you mentioned, peering would be the obvious one. This all depends on your security posture, how much you trust that third-party organization or that business. But within your AWS account, you can ultimately send a request to peer with them. Once they accept, that will peer your VPCs. Obviously, issues that come with that is sometimes they're using the same address space as you. So there may be technical hurdles to overcome there. You might have to create another subnet or some sort of NAT gateway to enable that communication. But that is the easiest way.
Okay. And from that perspective, what have I got any security considerations beyond the fact that it is a third party, or is it just fairly standard security consideration?
I think it's just fairly standard. I mean, you've got within AWS and Azure, you've got the host-based access list and security rules, so you can use those. If you wanted to, you could put a third-party firewall in there to ensure that traffic's routed through a firewall. You can block it there. Like I said, excuse me, I don't really like going away from the cloud-native stuff because it then introduces more technical issues. And if they've got a firewall this side, what we've seen in the past is they're paired together, but they've actually created a tunnel over the top. So they're using things like GRE or even IPsec to create that relationship between the firewall their side and the business side, and that allows them to protect each other's equipment there. So you're essentially securing your boundary there. They've only got one route in and out. Again, they're paired just to enable these firewalls to talk together. You build a tunnel over the top, and then you've got your static routes each way to the VPCs.
And is there any reason why we would or we wouldn't bring these into a core network? So if you had a core network, and you know that a lot of core networks have like third-party landing zones, so we'd essentially have a scenario where we're cloud to out of cloud to back in cloud. Yeah. Is there a circumstance where that is actually of value? Is there a circumstance where actually it's just generally bad practice? What does that look like, and why might we go one way or indeed the other?
So yeah, ultimately you can get your providers to connect via the private constructs. So you've got ExpressRoute here, ExpressRoute there, and the data center there. What that allows you to do as the controlling business is you can push that through your security devices here. You've got control of all the routing. There's no tunneling mechanism which mess around with MTU may create additional complexities where you have to lower that MTU artificially. So you can port that to the data center. You could do all the inspection here, and then you could push it back up to cloud. And then that keeps your security down here. So you don't have these limitations or static routes here, and you've got full control. So that's another option.
So is it safe to say that actually neither's not necessarily better than the other? It might depend on your security posture or who you want to have the greater level of control on how to route or perform that function.
Yeah, exactly. And I think, like I said, as soon as you start getting into tunneling, GRE, IPsec, things like that, you are going to need those heavy networking skills to do that anyway. So if you've got the capacity in your data center, you've already got connectivity, you may as well just bring them in that way. So yeah, again, as well, you could ultimately make that a VPN if you wanted over the internet to the data center, then pipe them up to your own private cloud.
I suppose one thing for consideration as well is that we've looked at this as if it was a single VPC and a single VPC.
Yeah.
If we had multiple VPCs and they had multiple VPCs, we're actually bringing ourselves back to the transit architecture again, where it might be that from our perspective, it's a case of, look, I don't really have control of your architecture, so I just want one ingress and let you have your own problem. So that might be something that we're doing here as well. Again, so many different ways to look at this. This is just one of the things that cloud has introduced is that there's just so many different ways of doing things. Going back to data center networking, it was a bit more consistent. Bless the good old days. Easier to design for, but there's loads of good reasons that we should be looking at some of these things and trying to improve them. So another question that's coming in is there a right and wrong time to use VPC peering across the internet? I'm trying to think about what that might mean. I think this is, I'm going to try and unpick that. I think that might be a greater question about using the internet as a backbone. So I think I kind of alluded to it and kind of joked about it. Not sure there's necessarily something that we should draw more than sort of talk about that. I think one of the things that I would love to say we get asked a lot. We don't get asked a lot. We tend to hear a lot of opinion on is private networking, public networking. And by that, I mean using WANs as they are traditionally kind of known, provided by your typical telco type providers, or using the public internet. Why would I not essentially just use the public internet? It's there, it's cost effective, although the term usually used is cheap. It's quick, it is all these things versus private networking. And I think rather than me talk to this, I think it's worth you talk to this. We talk about this a lot, there is a myth that private networking is hyper expensive, is big, bad, ugly. People use the term MPLS completely wrongly. What are the sorts of things that the conversations we're having and kind of dispel a couple of those myths?
Yeah, so one on MPLS. So MPLS is just a technology. It stands for multi-protocol label switching. It essentially means traffic is switched faster or routed faster. Whether you're getting an internet provision or a private provision, the chances are that it's MPLS. Our internet backbone is MPLS, so is our private connectivity. So although it's not, the only difference is you don't get the SLAs, so there's no sort of quasi, it's all best effort and things like that. So if those pipes get saturated within your provider network, the private traffic is going to take priority because they pay for those SLAs, whereas the internet traffic will get dropped and then retransmitted. So they're the difference there. On the cost thing, again, our internet's actually more expensive to provide because you've got your last mile connectivity cost, you've then got your core connectivity cost, and then you've got internet connectivity or your transit provider cost on top of that. Whereas with the private connectivity, you've only got the first two, so it actually costs us more to provide internet than it does to provide a private circuit. Yeah,
I think that one is a real myth. I suspect what's happened is that the cost of a WAN and private circuits to companies from telcos over the years has been incredibly expensive, and rightly or wrongly without great thought. You've got this great big albatross here, and you've got probably what you're thinking about as just your broadband at your house here for what you would spend on internet. Of course, the reality is it's probably a little bit more balanced than that. But Steve is absolutely right that the cost to us is probably more effective to use private networking. And the fact is that the public internet is built on the same technologies. and that the internet is essentially just, for those of you who know about VRFs, it's just another VRF. It's not the great big magical thing that it's purported to be. So to come back to the question as to whether you should use your peering across the internet, and I think we've kind of taken this question and run with it a little bit, is there's always reasons for the what's, whys, and wheres. Usually we're looking at time and we're looking at money. They're going to be the two. So if I want to do something quickly, usually getting to the internet can be quicker because you have immediate control over it. Cost, again, that really does depend. If someone is trying to sell you private networking and it is absolutely ridiculously more than public internet, and I mean public internet beyond residential broadband, of course, then you should go and have a very serious chat with them, because there's something just very wrong. You know, there are considerations as well around security. That one comes out a lot. Don't want to delve too much into that from a design perspective, but it is something that we would want to think about as well. Security nowadays, when we use the public internet, is usually application-driven encryption. So at its most basic, for those of you who would go onto a website, HTTPS instead of HTTP. So it's actually the protocol is encrypting and doing the sort of basic, and it is basic, a security function at an application level. But of course, you know, one thing to consider is that when you're putting all of your traffic onto the internet, it is something that can be seen and can be pulled, albeit it's an encrypted algorithm, and that might be something for consideration as well, let alone other design thoughts around latency and packet loss and packet fidelity and stuff like that. So one of the things that we got during the week as a question was hub and spoke architectures. Essentially, it was asked slightly more colloquially than hey, hub and spoke architectures, what do you reckon? It was, hey, hub and spoke architectures are like cool when fax machines were cool, right? Not necessarily fair. There was, as there usually is, great fanboyism around all these wonderful new terms and technologies. We heard about distributed architectures and microservices and all these wonderful things. And there seems to be a complete misunderstanding of the fact that hub and spoke is actually very commonplace in everything we do, and you can't escape it, particularly if you understand what networking looks like in the UK backbone. So what, in your eyes, is the sort of immediate benefit of hub and spoke architecture? And also talk to us a little bit about what the UK looks like at the highest level, with like the major pops and how things work, and maybe it's a good opportunity to talk about local breakout, which sometimes comes out as well.
Yeah, so going back to the original sort of diagram I drew, where you've got your WAN provider. As you start connecting your sites into your WAN provider, you've essentially got hub and spoke technology anyway, because they're distributed throughout the UK. They'll be UK connectivity is heavily London-centric. If you do a trace route anyway, you're pretty much guaranteed to go through London at one point or the other. We've got a data center in Manchester, and like I said, getting there will go through London. Every company I work for is heavily London-centric with their connectivity, as are the service providers. So as you start putting sites on there, again, you've got hub and spoke technology. Essentially, your provider is providing that hub, and you're sitting on the spokes here at your LAN. Local internet breakout, again, we'll talk to this. So local internet breakout, it's not really local. I mean, I do get the concept. It is a breakout at the edge, but say your provider's giving you two connections. One's private and one's an internet link. That's still going to the same place. It's still going to the same data center. It's still being routed by the same tier one providers, and you're still just a spoke, essentially on the end of a hub. What it does mean on your site is obviously, rather than backhaul that via your WAN or via your data center, which we had connected up there, you can send that straight out onto you on that site. It looks like it's going straight to the internet, which it is, but it's essentially taking the same path. It's going to a hub provided there. One of the main data centers, it's then going to hit a provider, then a tier one provider, then going to get routed. And we have other things like internet exchange, things like that built into there, which providers will take advantage of. But yeah, I think, everyone will have a hub and spoke technology, even if they don't know about it.
Yeah. I think the reason that we like to talk about hub and spoke technologies is because It's something that comes up a lot. Local breakout, I say with a wry smile, because as Steve is pointing out, like just to give it, a high level visual, it pulls back to the same place. In fact, often to get out to the internet, you're coming back to the same data centers as you would have your private access to public cloud, maybe even where you're hosting your services. But it sounds wonderful. Local breakout sounds like it literally kind of fairy dust just appears on the internet. That's simply not what it does. But this session is about design. So what's the design thing that we're talking about here? I think for me, this would be an example of ill-considered design. I've had plenty of conversations with people that say, I need local breakout. Local breakout is better. Or local breakout is modern versus I don't want what I used to have, which is I have to go all the way across my WAN to my data center to get out on the internet. Well, unfortunate news for you. You are going all the way, as Steve shows you, across a WAN to a data center to get out to the internet. So to me, if you're making decisions on technologies you may be buying, SD-WAN is a classic. We need SD-WAN because we need local internet breakout. Well, actually, there's a way that we can do many things at the network level. I'm not talking about all the other function that SD-WAN offers, of course. That's a very separate discussion. But if that is your key concern, that perception of local internet breakout, I need to get to the internet quicker, then it is a misguided one. In fact, I would go as far as saying just completely incorrect. So that would be poor design. And if that leads you to ultimately buying an SD-WAN setup that you just didn't want or need, it would also be a very costly one as well.
Yeah, I think what this does offer is, we used to have the WAN, typical WAN here, then you go to the data center, you break out on the firewall. What we're typically seeing now with the local breakout model is every site gets a firewall, essentially. So you can push your Office 365 traffic and stuff like that. It removes the reliance on the data center. That's more of the design you think about. It's all about, let's remove the reliance on that firewall so we don't have to manage that. We've got high availability pairs on each site, and we're breaking out locally. We're managing it from the site. I think ultimately that is, sorry, that's the reason, all the misconception about local breakout. It's not about breaking out locally. It's about removing the reliance on the data center. So then if anything goes wrong in here, you've still got internet access here.
Yeah. And it's interesting when we talk about the security function there as well, because the reality is, yeah, that does pull a security function nearer to the source, which definitely almost always will be seen as good design. I think that's good. But at the same time, if that is important, if this is a security-driven design, a security-driven decision, it is safe to say that the security quality in SD-WAN boxes for most of the leading market vendors is not the same as something that ultimately is there to be the grunt and guts of a security only device.
Yeah, no, I know the firewall vendors are obviously developing that, Fortinet, Palo Alto, so things like that. So SD-WAN's been sort of an afterthought to them, and it is really emerging now, and they've got the good products on the market. But yeah, things like Meraki and things like that, that sort of stuff. It was SD-WAN first, security afterwards. So yeah, definitely. We're definitely getting there.
Yeah, which is good. But say as a design consideration, this is one I think we sort of, I mean, we obviously do know because we talk about this all the time. But SD-WAN can be a bit of a bugbear because it's a marketing term first than anything else, and so it's not considered. It can be very frustrating from a design perspective. So I think we're probably heading towards the end of the session. I think one of the things that has come up in conversation, we've obviously talked about this a lot, is extrapolation of a technology from the cloud. So we talked about, we've said from the start, and again, these are conversations that we've had with Amazon and Microsoft. So this is not some kind of weird sideswipe at all. This is exactly what we engage them in quite regularly. Public cloud wasn't built for networking. It simplified some basic network functions to allow those who it was aimed at to be able to use it in the most efficient way. And of course, we said that things have started to change, so we need to design accordingly. As you can imagine, and again, no shade thrown, the vendors of network devices, traditionally hardware, needed to get in on this next big thing and to get into cloud. And I think it's been a learning lesson for them in how to function on top of something that, again, isn't typically network. So we've talked about, well, can we extrapolate the function out of? Why do we have to perform the network function inside of the cloud? Why don't we actually leave it as was intended and take as much as possible of the network function outside of the cloud, such that you can use the nice native tools for what was designed for, applications and services? So what's your thoughts on that? And maybe, talk to us about how and what we can take out, and what that would look like.
Let me get a different color pen. So yeah, I mean, you can definitely take the network function out of cloud. So you've got your VNet or VPC here, and it's something we provided in the past. We've got your private connectivity here, and you've got your security functions, your data center functions, everything else, all those good stuff, even your WAN if you want. And ultimately, really, if you wanted to, rather than use internet in cloud and the internet gateways, you can actually provide that here. So you're bringing that down, again, using routing protocols, you just simply advertise a default route to that VPC. That essentially means all traffic then would come down here. You could do all your inspection, your hardware-based appliances with the ASICs and the good stuff they've got there. They've got a lot more throughput than the virtual device in cloud. And you can provide internet access there, you can provide security, you can provide connectivity everywhere else. So ultimately, yes, you could. If you start putting things in cloud, like I said, that starts to get complex because your virtual machines can't interact with the underlying fabric. They can't interact with the VPCs or VNets and run BGP with them. You're ultimately relying on static routing or ingress routing or one of those here. Here, we can just advertise a nice route and we take all the traffic.
And presumably this kind of becomes exacerbated when there's multi-cloud. So we've got, we're talking about what, a VNet or a VPC. If you had a Microsoft and you had an Amazon, in being able to take two functions out, we've now got a consistent function. We've got a single source of truth.
Yeah.
And I guess I'll state the obvious, that starts to generate an economy of scale because we can start to make that potentially more cost effective, right?
Yeah, exactly. Yeah, so you connect your second cloud. Again, they're fully routable. And using the same devices, security, all the policies and postures you've got here, you don't have to run another machine in here. You've not got the overhead of managing that, things like that. So everything's still done here. Another design consideration is if you're running multiple, let's say we've got 2 Microsoft clouds connected there, that BGP autonomous system numbers you need to be aware of. So Microsoft use the autonomous system number 12076. By default, you can change that. But ultimately, if you wanted to get from here to here, using the same autonomous system number, that wouldn't happen. So BGP's got a loop prevention mechanism, which means if it sees its own autonomous system number in the path, it will essentially drop that route. So what we have to do when we've seen this with customers, we have to essentially do what's called AS override in both these places. So that will remove that AS number and basically replace it with our AS number, and then the routes can flow freely. Obviously, you've lost loop prevention at that point, so that's another consideration. How do you stop routes from here going to here and getting routed back here? Or if you've got a VPN over the top, you could end up with routing loops. So again, that's another consideration we have to deal with quite a lot. And we have mechanisms in place to stop that. We use things like BGP communities and other mechanisms to stop those looping. Excuse me.
Yeah, I think in here, the conversations that we have usually comes down to, again, time and money, right? So again, belief that, not from everyone, I hasten to add, but there's a belief that cloud is more cost effective than not cloud. I think there are vast parts of it that absolutely is the case, but when the design is poor and the sprawl is great, sadly, that's not the case. So yes, things can be spun up quickly. Yes, you want to get going, get all of that makes sense. If I need to be doing things and extrapolate it out here, is it going to cost more? Almost certainly not. Is it going to take more time? Now, here's where it gets interesting, because you will almost certainly be sitting there thinking, well, this all has to be hardware. So if we are to do this, we're going to have to go and position ourselves in physical data centers. We're going to have to go and order hardware. We're just kind of going backwards, right? So whilst this looks like a nice design and I get the theory, we're going backwards. It doesn't need to be. What if all of that is essentially sitting in another cloud? It's just network cloud. and it delivers in exactly the same way that you want. You get to press the button and the thing appears, or you get to grow it just like the cloud-like experience you get up here, but it is built in a way and on a foundation, its own foundation that was actually built and intended for networking. So this is a discussion that has been very difficult, particularly for us and from a design perspective, because it feels like we're taking things away from people up here. But I think it's a very interesting consideration, particularly when if time is the same or better and cost is better, and it sits on what is essentially designed for networking, this definitely also becomes a way that we can approach things as well. Sadly, there are a million things that we can talk to you with great enthusiasm about in the wonderful world of networking, but we have come to the end. Just like to say a big thank you for all of you who have joined us today. Reiterate the fact that we are wanting this to become a community. We want to start to grow something through more than these 3 sessions. Thank you so much for those of you that put something into the chat to give us something to talk about. We have our 3rd and final session of these 3 next week, which is going to be based on deployment and troubleshooting. So much like this past week, it would be great for us if you have any questions. If you have something live that needs fixing, I suggest you probably want to get it fixed quicker. But if you do have an example of something that was complex, or maybe something that you learned, or maybe ask us the question about how would you have handled a scenario in which ... that would be really useful. We can, of course, create some synthetic scenarios, which will give you some examples of how to approach troubleshooting based on good design, based on bad design as well. And that will then conclude our 3 sessions, and we will move on from there. So without anything else to say, apart from, again, one final thank you and apologies for the cutout at the start. It's what it is all about, I am afraid. A networking issue. Thank you very much, and see you next week.
Cheers, thank you.